What if everything you thought you knew about the universe was just the tip of the iceberg? Imagine staring into the night sky, only to realize that the stars above might be hiding secrets so terrifying they could rewrite the very fabric of reality. Today, we're diving into the 30 most terrifying space theories that will make you question everything you've ever believed about the cosmos. From the chilling possibility of a universe-ending catastrophe to the eerie silence that suggests we might be utterly alone, these theories don't just challenge our understanding of space, they shatter it. So buckle up, because by the end of this video, you'll be left wondering if the universe is a place of wonder or a cosmic nightmare waiting to unfold. Let's begin. Now let's dive into the first theory that will send shivers down your spine, the Big Crunch. Picture this: the universe, which has been expanding since the Big Bang, suddenly stops growing. Instead of continuing to stretch out into infinity, it begins to collapse back in on itself. This is the essence of the Big Crunch theory. Scientists believe that if the gravitational pull of all the matter in the universe becomes strong enough, it could reverse the expansion, pulling everything back into a single, unimaginably dense point, a singularity. The implications of this are nothing short of apocalyptic. If the Big Crunch were to happen, it wouldn't just mean the end of galaxies, stars, and planets. It would mean the end of time and space as we know it. Imagine the entire universe, with all its complexity and beauty, being crushed into a single, infinitely small point. It's a scenario that challenges our very understanding of existence. But here's where it gets even more unsettling. The Big Crunch isn't just a one-way ticket to oblivion. Some theories suggest that this collapse could trigger another Big Bang, creating a new universe in a never-ending cycle of birth, death, and rebirth. While this might sound like a cosmic reset button, it raises terrifying questions about the nature of reality. Are we just one iteration in an endless loop of universes? And if so, what happens to everything we've ever known or experienced? The scientific community is divided on this theory. Some argue that the evidence for the universe's expansion accelerating rather than slowing down makes the Big Crunch unlikely. Others point to the mysterious force of dark energy, which could eventually reverse its effects, pulling the universe back together. The debate continues, but one thing is certain: the Big Crunch forces us to confront the fragility of our existence and the possibility that everything we know could one day vanish in an instant. As we move forward, keep this chilling thought in mind: the universe might not be as eternal as it seems. And with that, let's explore another theory that will make you question the very fabric of reality. Now let's shift our focus to a theory that paints a very different yet equally chilling picture of the universe's fate: the heat death of the universe. Unlike the dramatic collapse of the Big Crunch, this theory suggests a much slower, more gradual end. It all comes down to a concept called entropy, which is essentially a measure of disorder in a system. Over time, entropy increases, meaning that energy becomes more and more evenly distributed. Imagine the universe as a cup of hot coffee left on the counter. At first, it's steaming and full of energy, but as time passes, the heat dissipates and the coffee cools down until it reaches room temperature. In the same way, the universe is slowly losing its usable energy. Stars will burn out, galaxies will drift apart, and eventually all the energy in the cosmos will be spread so thin that nothing can happen anymore. No new stars will form, no planets will orbit, and no life will exist. The universe will become a cold, dark, and lifeless void. This process isn't sudden or violent, it's a slow, inevitable decline. Over trillions of years, the universe will reach a state of maximum entropy where everything is in perfect equilibrium. At that point, there will be no temperature differences, no energy gradients, and no way for any work or activity to occur. It's like a clock winding down until it finally stops, leaving behind only stillness. What makes this theory so unsettling is its inevitability. Unlike the Big Crunch, which depends on the universe's expansion reversing, The heat death is based on the laws of thermodynamics, which are fundamental to our understanding of physics. It's not a question of if, but when. And while the timescale is almost unimaginable, far beyond the lifespan of stars, galaxies, or even civilizations, it forces us to confront the idea that the universe as we know it is finite. So, while the heat death might not be as dramatic as other cosmic doomsday scenarios, it's perhaps the most certain. It's a reminder that even the vast, seemingly eternal cosmos is subject to the same laws that govern everything else. And with that thought lingering in your mind, let's turn to another theory that will challenge your perception of reality even further. Now, let's venture into one of the most perplexing mysteries of the cosmos, the Fermi paradox. Named after physicist Enrico Fermi, this theory revolves around a simple yet haunting question. If the universe is so vast and filled with countless stars and planets, why haven't we found any evidence of extraterrestrial life? The numbers alone make this question baffling. Our galaxy, the Milky Way, contains hundreds of billions of stars, many of which are orbited by planets in the so-called habitable zone, where conditions might support life. With such staggering odds, it seems almost impossible that we're alone. And yet, despite decades of searching, we've found no signs of intelligent civilizations. So, where is everyone? One possible explanation is that advanced civilizations tend to self-destruct before they can make contact with others. Imagine a species developing technology powerful enough to explore the stars, but also destructive enough to wipe itself out. Nuclear war, environmental collapse, or runaway artificial intelligence could all be potential pitfalls. If this is true, it raises a chilling question. Are we, as a species, heading down the same path? Another possibility is that intelligent life is deliberately avoiding contact. This idea, often referred to as the zoo hypothesis, suggests that extraterrestrial civilizations might be observing us from a distance, much like we study animals in a nature reserve. They could be waiting for us to reach a certain level of technological or ethical maturity before making contact. Or they might simply see us as too primitive to engage with. Then there's the darker side of the paradox, the idea that the universe is inherently dangerous. Advanced civilizations might be hiding to avoid detection by others who could pose a threat. In this scenario, the cosmos becomes a kind of dark forest, where silence and secrecy are the keys to survival. If true, this paints a grim picture of the universe as a place where trust is rare and danger is ever present. The Fermi paradox doesn't just challenge our understanding of the universe, it forces us to confront our own future. Are we destined to remain isolated, or will we one day make contact with another civilization? And if we do, will it be a moment of unity or a harbinger of conflict? These questions linger as we continue our journey through the cosmos, searching for answers in the vast, silent expanse of space. With that thought in mind, let's turn to another theory that delves even deeper into the mysteries of existence, the Great Filter. Now, let's shift our focus to a theory that could explain why the universe seems so eerily silent. The Great Filter. This concept suggests that there's some kind of barrier, a critical challenge that prevents civilizations from advancing to the point of interstellar travel. The terrifying question is, where does this filter lie? Is it behind us or is it still ahead? One possibility is that the Great Filter is in our past. This would mean that the conditions necessary for life to emerge and evolve into intelligent beings are so rare and improbable that we're one of the very few, or perhaps the only civilizations to have made it this far. Think about it, the odds of a planet having the right conditions for life, the right chemical reactions to spark it, and the right environment to sustain it over billions of years are astronomically low. If this is the case, it could mean that the universe is mostly empty, with life being an extraordinary fluke. But what if the Great Filter is still ahead of us? This is where things get truly unsettling. If the filter lies in our future, it could mean that civilizations inevitably face a catastrophic event that prevents them from reaching the stars. This could be anything from self-destruction through war or environmental collapse to the rise of uncontrollable artificial intelligence, or even a natural disaster like a gamma-ray burst wiping out all advanced life. If this is true, it raises a chilling question. Are we, as a species, on the brink of encountering this filter? The Great Filter isn't just a scientific theory, it's a profound existential question. It forces us to confront the fragility of our existence and the uncertainty of our future. If the filter is behind us, we might be alone in the universe, a rare and precious anomaly. But if it's ahead of us, the stakes couldn't be higher. Every decision we make, every technological advancement we pursue, could determine whether we survive or vanish into the cosmic void. This theory doesn't just challenge our understanding of the universe, it challenges us to think deeply about our place in it. Are we destined to overcome the Great Filter and spread across the stars, or are we doomed to be just another fleeting spark in the darkness? The answer, for now, remains hidden in the vast, silent expanse of space. With this unsettling thought in mind, let's turn to another mind-bending theory that questions the very nature of reality, the simulation hypothesis. Now let's dive into a theory that might make you question everything you think you know about reality, the simulation hypothesis. This idea suggests that our entire universe, including everything in it, could be an incredibly advanced computer simulation created by a civilization far more technologically advanced than our own. Imagine this: what if everything you see, feel, and experience is just lines of code in a program so complex that it's indistinguishable from reality? The roots of this theory stretch back to philosophical debates about the nature of existence, but it's gained traction in recent years thanks to advancements in technology. Think about how far we've come with virtual reality and artificial intelligence. If we can create immersive simulations now, what's stopping a more advanced civilization from creating one so detailed that the beings inside it, like us, would never realize they're living in a simulation? Some scientists and philosophers argue that the odds of us living in a base reality, the real universe, are incredibly slim. If advanced civilizations exist, they might create countless simulations, each with its own simulated beings. Statistically, it's more likely that we're in one of those simulations rather than the original reality. This idea is both fascinating and deeply unsettling. It raises questions about free will, the nature of consciousness, and whether anything we experience is truly real. But not everyone is convinced. Critics of the simulation hypothesis point out that there's no concrete evidence to support it. They argue that while it's an interesting thought experiment, it's impossible to prove or disprove with our current understanding of science. Others suggest that even if we are in a simulation, it doesn't change the fact that our experiences feel real to us. In other words, does it really matter if reality is base or simulated if we can't tell the difference? Still, the implications of this theory are profound. If our universe is a simulation, who created it? Are we part of an experiment, a form of entertainment, or something else entirely? And if we ever discovered the truth, how would it change the way we live our lives? The simulation hypothesis doesn't just challenge our understanding of reality, it forces us to confront the possibility that everything we know might be an illusion. As we grapple with these mind-bending questions, let's turn our attention to another chilling theory that paints the universe as a dangerous place, the dark forest theory. Now, let's step into a universe that feels more like a shadowy, unpredictable wilderness, the dark forest theory. This chilling idea paints the cosmos as a place where civilizations stay hidden, fearing the consequences of revealing themselves. Imagine the universe as a vast, dark forest where every civilization is like a hunter, silently moving through the trees, afraid to make a sound. Why? Because in this forest, the first rule of survival is simple: don't draw attention to yourself. The dark forest theory takes the Fermi paradox, the question of why we haven't found evidence of extraterrestrial life, and offers a grim explanation. It suggests that advanced civilizations might be deliberately avoiding contact, not out of disinterest but out of fear. In a universe where resources are finite and technology can be weaponized, revealing your existence could be a death sentence. After all, if another civilization perceives you as a threat, they might decide to eliminate you before you can do the same to them. This theory is rooted in the idea that the universe is inherently dangerous. Civilizations that broadcast their presence risk attracting the attention of others who might be more advanced, more aggressive, or simply paranoid. The safest strategy, then, is to stay silent, observe, and never reveal your location. It's a cosmic game of hide and seek where being found could mean annihilation. But what does this mean for humanity? If the dark forest theory is true, our efforts to search for extraterrestrial life, like sending out signals or building telescopes to scan the skies, might be incredibly risky. Some scientists argue that we should be cautious about announcing our presence to the universe, as we have no way of knowing who or what might be listening. Others believe that staying silent might not be enough, as our technological footprint, like radio waves and space probes, could already be detectable by advanced civilizations. The implications of this theory are both fascinating and terrifying. It suggests that the universe isn't just vast and mysterious, it's also hostile. Civilizations that survive are the ones that master the art of secrecy, avoiding detection at all costs. This raises profound questions about our place in the cosmos. Are we alone because everyone else is hiding? And if so, should we be hiding too? As we ponder these unsettling possibilities, let's shift our focus to another cosmic threat that could erase the universe as we know it, the vacuum decay catastrophe. Now, let's turn our attention to a cosmic doomsday scenario that could rewrite the rules of existence itself, the vacuum decay catastrophe. Picture this: somewhere in the universe, a tiny bubble of true vacuum forms. It might sound harmless, but this bubble could be the beginning of the end. According to this theory, our universe exists in a false vacuum state, a kind of cosmic balancing act. But if this balance is disrupted, a bubble of true vacuum could emerge, and once it does, it would expand at the speed of light, rewriting the fundamental laws of physics as it goes. Here's how it works. The universe is governed by certain constants like the speed of light or the strength of gravity that make life as we know it possible. But these constants aren't set in stone. They're the result of the universe being in a false vacuum state, a kind of temporary stability. If this state were to collapse into a true vacuum, the laws of physics could change instantly. The bubble of true vacuum would spread outward, destroying everything in its path. Stars, planets, even atoms themselves would cease to exist as we know them. The universe as we know it would be erased, replaced by something entirely different and likely uninhabitable. What makes this theory so terrifying is its unpredictability. A vacuum decay event could happen at any moment, anywhere in the universe. There would be no warning, no way to prepare. One moment, everything is normal. The next, a wave of destruction is racing toward us at the speed of light. By the time we realized what was happening, it would already be too late. The bubble would engulf Earth and everything on it in an instant. Scientists believe that vacuum decay could be triggered by a random quantum fluctuation, a tiny, unpredictable event at the subatomic level. It's like a cosmic game of chance where the stakes are the entire universe. And while the odds of this happening are incredibly low, the consequences are so catastrophic that the mere possibility is enough to send shivers down your spine. This theory forces us to confront the fragility of existence. It reminds us that the universe is governed by forces we don't fully understand, and that even the most fundamental aspects of reality could change in an instant. As we grapple with this unsettling idea, let's move on to another cosmic threat that's equally unpredictable: the rogue black hole threat. Now, let's shift our focus to a cosmic menace that could come barreling into our solar system without warning: the rogue black hole threat. Imagine a black hole untethered from any galaxy, drifting silently through the void of space. These rogue black holes are the ultimate cosmic nomads, and if one were to cross paths with our solar system, the consequences would be nothing short of catastrophic. Black holes are already some of the most mysterious and destructive objects in the universe. Their gravitational pull is so intense that not even light can escape them. But a rogue black hole is even more terrifying because it's not anchored to a specific location. It's free to roam, and if it were to wander into our cosmic neighborhood, it could wreak havoc on a scale we can barely comprehend. Here's how it could play out. A rogue black hole entering our solar system would begin to distort the orbits of planets, moons, and even the sun itself. The delicate gravitational balance that keeps our solar system stable would be thrown into chaos. Planets could be flung out of their orbits, sent hurtling into the void of space or colliding with one another. Earth's orbit could be altered dramatically, leading to extreme climate shifts or even ejection from the solar system entirely. And if the black hole got close enough, it could consume our planet whole, pulling everything into its inescapable grip. What makes this scenario so chilling is its unpredictability. Rogue black holes are incredibly difficult to detect because they don't emit light. They could be lurking in the darkness of space, invisible to our telescopes until it's too late. By the time we noticed its gravitational effects, the damage might already be done. There's no way to predict when or where one might appear, making this threat all the more unsettling. Scientists estimate that there could be millions of rogue black holes scattered throughout the Milky Way, remnants of ancient galaxies or the aftermath of cosmic collisions. While the odds of one entering our solar system are astronomically low, the sheer scale of the universe means it's not impossible, and the consequences would be so devastating that even the remote possibility is enough to keep astronomers on edge. This theory forces us to confront the fragility of our place in the cosmos. It reminds us that the universe is filled with dangers we can't always see or predict. As we ponder the terrifying potential of rogue black holes, let's turn our attention to another mind-bending concept: the false vacuum state, and how it could rewrite the very fabric of reality. Now, let's venture into a theory that challenges the very foundation of our reality: the false vacuum state. Picture the universe as a delicate bubble floating in a sea of possibilities. What if that bubble isn't as stable as we think? What if at any moment it could pop, rewriting the laws of physics as we know them? This is the unsettling idea behind the false vacuum state. Our universe, as we understand it, exists in what scientists call a metastable state. Think of it like a ball resting on the edge of a hill. It's stable for now, but with the right nudge, it could roll down into a valley, a lower energy state. If this were to happen, the consequences would be unimaginable. The transition could start with a tiny quantum fluctuation, a random event so small it's almost impossible to detect. But once it begins, it would spread at the speed of light, altering the fundamental forces that hold matter together. Imagine the laws of physics as we know them: gravity, electromagnetism, the strong and weak nuclear forces suddenly changing. Atoms, the building blocks of everything, could no longer exist in their current form. Stars, planets, and even life itself would be obliterated in an instant. The universe as we know it would cease to exist, replaced by something entirely different. And here's the most terrifying part: there would be no warning, no way to predict or prevent it. It could happen at any moment, anywhere in the universe, and we wouldn't see it coming until it was too late. This theory isn't just science fiction. It's rooted in the principles of quantum field theory, which suggests that the vacuum of space isn't truly empty but filled with energy. If our universe is in a false vacuum, it's like living on borrowed time. The stability we take for granted could be an illusion, and the transition to a true vacuum state could be inevitable. Some scientists argue that this might have already happened in other parts of the universe, creating bubbles of destruction that are expanding outward, unseen and unstoppable. The false vacuum state forces us to confront the fragility of existence. It reminds us that the universe is governed by forces we're only beginning to understand, and that even the most fundamental aspects of reality could be subject to sudden, catastrophic change. As we grapple with this mind-bending concept, let's turn our attention to another cosmic mystery, the Quantum Immortality Paradox, and how it challenges our understanding of life, death, and the nature of reality itself. Now, let's dive into a theory that bends the very fabric of existence, the Quantum Immortality Paradox. Imagine a world where death isn't the end, but rather a doorway to infinite possibilities. This mind-bending concept suggests that every time you face a life-threatening situation, your consciousness splits into parallel universes, creating the illusion that you never die. In one universe, you might survive a car crash, while in another, the outcome is tragically different. But here's the twist: your awareness only continues in the universes where you live, making it seem as though you're immortal. At its core, this theory is rooted in the many worlds interpretation of quantum mechanics, which proposes that every possible outcome of a quantum event spawns a new universe. So, if you were to step off a cliff, there's a universe where you fall to your demise, and another where you somehow survive. Your consciousness, however, would only experience the reality where you live, leaving you unaware of the countless versions of yourself that didn't make it. It's a chilling thought. What if you're not truly immortal, but simply experiencing an endless series of near misses across infinite realities? The implications of this paradox are both fascinating and deeply unsettling. For one, it challenges our understanding of life and death. If consciousness can persist across parallel universes, does death even exist in the way we think it does? And what does this mean for our sense of self? Are we just one version of an infinite number of yous, each living out different lives in different realities? The idea that you could be experiencing endless versions of yourself, each unaware of the others, is enough to make anyone question the nature of reality. But the quantum immortality paradox doesn't just stop at existential questions, it also raises ethical dilemmas. If you believe you're immortal in this sense, would you take greater risks knowing that your consciousness might continue in another universe? And what about the universes where you don't survive? Are those versions of you simply erased, or do they continue in some form? These questions blur the line between science and philosophy, leaving us to grapple with the eerie possibility that our lives are far more complex and interconnected than we ever imagined. As we ponder the unsettling implications of this theory, let's shift our focus to another cosmic enigma, the Boltzmann Brain, and how it challenges our understanding of consciousness and the very fabric of reality. Now, let's venture into one of the most bizarre and unsettling theories in cosmology, the Boltzmann Brain. Picture this: floating in the vast emptiness of space, a fully formed, self-aware brain suddenly comes into existence, complete with memories, thoughts, and a sense of identity. Sounds like science fiction, right? But according to this theory, it's not only possible, it might even be more likely than the existence of the universe as we know it. The Boltzmann brain concept stems from the idea of random quantum fluctuations. In an infinite universe, given enough time, even the most improbable events can and will happen. This means that, theoretically, a conscious brain could spontaneously form out of nothing, complete with fabricated memories and experiences. It's a thought experiment that pushes the boundaries of what we consider possible, forcing us to question the very nature of reality. But why is this theory so unsettling? For starters, it challenges our understanding of consciousness. If a Boltzmann brain can form with all the same thoughts and memories as you or me, how do we know we're not one of them? What if everything we perceive as reality is just a fleeting illusion, conjured up by a random fluctuation in the void? It's a chilling possibility that undermines our trust in our own experiences and the world around us. The implications don't stop there. If Boltzmann brains are more probable than the existence of an entire universe, it raises questions about the nature of existence itself. Why does the universe seem so orderly and structured if randomness can produce conscious entities? And if Boltzmann brains are out there, how would we even know? These questions blur the line between science and philosophy, leaving us to grapple with the eerie idea that our reality might be far more fragile and far stranger than we ever imagined. As we wrestle with the mind-bending implications of the Boltzmann brain, let's turn our attention to another cosmic mystery, the multiverse collision, and how it could reshape everything we know about existence. Now, shifting our gaze to an even grander cosmic scale, let's explore the multiverse collision, a theory that suggests our universe might not be alone. Imagine a scenario where our universe, like a bubble floating in an endless sea, bumps into another universe. What happens next? The consequences could be nothing short of apocalyptic. The multiverse theory proposes that our universe is just one of countless others, each with its own set of physical laws and properties. These universes could exist side by side, separated by dimensions we can't perceive. But what if the barriers between them were to break? A collision between two universes could unleash unimaginable forces, reshaping everything we know. The aftermath of such a collision is hard to predict. In some scenarios, the two universes might merge, creating a new reality with entirely different laws of physics. Stars, planets, and even the fabric of space-time could be torn apart and reassembled in ways we can't comprehend. In other cases, the collision could lead to mutual destruction, obliterating both universes in a cataclysmic event. The sheer scale of such an event is almost beyond human imagination, yet it's a possibility that scientists take seriously. What makes this theory so terrifying is its unpredictability. If a collision were to occur, we might not even see it coming. The forces at play would be so vast and alien that our understanding of physics might not apply. It's a reminder of how fragile our existence could be in the grand scheme of the multiverse. As we ponder the potential chaos of a multiverse collision, let's turn our attention to another enigmatic concept, the alien zoo hypothesis, and what it might mean for humanity's place in the cosmos. Now, let's venture into a theory that challenges not just our understanding of the cosmos, but our very sense of self, the alien zoo hypothesis. Picture this. What if humanity isn't alone in the universe, but instead we're being watched? Not by distant, indifferent observers, but by advanced civilizations who have chosen to keep us isolated, like animals in a cosmic zoo. This theory suggests that extraterrestrial beings might be fully aware of our existence but have decided to avoid direct contact. Why? Perhaps they see us as too primitive, too volatile, or even too dangerous to interact with. Just as we might observe animals in a wildlife preserve without interfering, these advanced civilizations could be studying us from afar, ensuring we remain undisturbed in our natural habitat. But this raises profound ethical and existential questions. If we are being observed, what does that say about our place in the universe? Are we merely subjects in an experiment, or is there a deeper purpose to our isolation? The idea that we might be deliberately kept in the dark is both humbling and unsettling. It forces us to confront the possibility that we are not the masters of our own destiny, but rather part of a larger, incomprehensible design. What's more, this theory challenges our assumptions about the search for extraterrestrial life. If advanced civilizations are intentionally avoiding us, then our efforts to make contact through radio signals, space probes, or other means might be futile. It's a sobering thought, one that shifts the focus from "Are we alone?" to "Why are we being ignored?" As we grapple with these questions, the alien zoo hypothesis serves as a stark reminder of how little we truly understand about the universe and our role within it. It's a theory that doesn't just terrify, it humbles, leaving us to wonder if we're ready to face the truth, should it ever be revealed. With this thought lingering in our minds, let's turn to another mystery that bends the very fabric of reality, the time loop theory, and the possibility that the universe might be stuck in an endless cycle of birth, expansion, and collapse. Now, let's step into a theory that twists our understanding of time itself, the time loop theory. Imagine the universe not as a linear journey from beginning to end, but as an endless cycle, repeating itself over and over again. This idea suggests that the cosmos is stuck in an infinite loop of birth, expansion, and collapse, with each iteration resetting the clock and starting anew. At the heart of this theory is the concept that the universe could be destined to repeat its history endlessly. Every star, every galaxy, and even every life form might exist again and again, trapped in a cosmic Groundhog Day. The Big Bang, the formation of galaxies, the rise of civilizations, all of it could be part of a never-ending cycle, playing out in exactly the same way each time. But what does this mean for us? If the time loop theory is true, then every decision, every moment, and every event has already happened countless times before. The choices we make, the lives we lead, might not be unique at all. Instead, they could be part of an infinite replay with no possibility of escape or change. It's a chilling thought, one that challenges our sense of free will and individuality. This theory also raises questions about the nature of time itself. Is time truly linear as we perceive it, or is it more like a spiral, looping back on itself endlessly? Some scientists speculate that the universe's expansion and eventual collapse could create the conditions for a new Big Bang, restarting the cycle. Others suggest that the laws of physics might allow for slight variations in each loop, introducing tiny changes that could accumulate over countless cycles. Yet, even with these possibilities, the time loop theory leaves us with a profound sense of inevitability. If the universe is doomed to repeat itself, then everything we know, our achievements, our struggles, our very existence, might be part of an eternal pattern with no beginning and no end. As we ponder this theory, it's hard not to feel a mix of awe and unease. The idea of an endless cosmic loop forces us to confront the possibility that our lives and the universe itself might be far more cyclical than we ever imagined. With this mind-bending concept still lingering, let's shift our focus to another cosmic mystery, the white hole mystery, and the strange, unpredictable phenomena that could be lurking in the depths of space. Now, let's turn our attention to a cosmic phenomenon that feels like something straight out of science fiction, the white hole mystery. While black holes are known for their immense gravitational pull, trapping everything that crosses their event horizon, white holes are theorized to be their exact opposite. Instead of pulling matter in, white holes are thought to violently eject matter and energy into the universe, acting like cosmic fountains that defy our understanding of space and time. The concept of white holes emerges from the equations of general relativity, the same framework that predicts black holes. If black holes are regions where nothing can escape, white holes are regions where nothing can enter. They are essentially the reverse of black holes, spewing out light, energy, and matter in a way that seems to violate the laws of physics as we know them. But here's the catch: white holes are purely theoretical. No one has ever observed one, and their existence remains one of the greatest mysteries in astrophysics. Some scientists speculate that white holes could be connected to black holes through wormholes, forming a bridge between 2 points in space-time. Others suggest that white holes might be the remnants of black holes that have reached the end of their life cycle, exploding in a burst of energy and matter. The unpredictability of white holes adds to their eerie allure. If they do exist, their behavior would be chaotic and uncontrollable, releasing vast amounts of energy in sudden, violent outbursts. Imagine a cosmic event so powerful that it could reshape entire galaxies, yet so elusive that we might never detect it directly. The possibility of white holes existing in our universe raises profound questions about the nature of space-time and the balance of cosmic forces. Could they be the key to understanding the origins of the universe, or are they simply mathematical curiosities with no real-world counterpart? For now, the mystery remains unsolved, leaving us to wonder what other secrets the cosmos might be hiding. As we contemplate the enigmatic nature of white holes, let's prepare to dive into another mind-bending theory, the quantum suicide paradox, where the boundaries of reality and consciousness blur in ways that challenge everything we think we know. Now, shifting our focus to a theory that bends the very fabric of reality, we arrive at the quantum suicide paradox. This thought experiment takes the bizarre principles of quantum mechanics and applies them to the concept of consciousness, leading to a chilling conclusion about the nature of existence. The quantum suicide paradox is rooted in the idea of quantum superposition, where particles can exist in multiple states simultaneously until observed. Extending this to human experience, the theory suggests that every decision we make creates a branching of parallel realities. In one reality, you might survive a dangerous situation, while in another you might not. But here's the twist. Your consciousness only continues in the realities where you survive, creating the illusion of immortality. Imagine a scenario where someone repeatedly attempts a life-threatening experiment, like firing a gun at their head. According to this theory, in some realities the gun fires and the person dies, but in others the gun fails and the person lives. From the perspective of the individual, they only experience the realities where they survive, making it seem as though they are invincible. This paradox raises profound questions about the nature of consciousness and reality. Are we truly experiencing all possible outcomes, or is our perception limited to a single, continuous thread of existence? The idea challenges our understanding of free will, suggesting that every choice we make might be leading us down an infinite web of alternate realities. The philosophical implications are equally unsettling. If the quantum suicide paradox holds true, it could mean that our sense of self is an illusion, fragmented across countless parallel universes. It also forces us to confront the possibility that death, as we understand it, might not be the end, but rather a transition into a reality where we no longer exist. As we grapple with these mind-bending ideas, we're reminded of how little we truly understand about the universe and our place within it. The quantum suicide paradox doesn't just challenge our perception of reality, it forces us to question the very nature of existence itself. With this thought-provoking theory fresh in our minds, let's turn our attention to another cosmic mystery, the Boltzmann Brain, a concept that takes the strangeness of quantum mechanics to an entirely new level. Now, let's venture into a theory that challenges our understanding of advanced civilizations and their place in the cosmos, the Dyson dilemma. This concept revolves around the idea of Dyson spheres, hypothetical megastructures built by highly advanced civilizations to capture the energy of stars. Imagine a civilization so advanced that it constructs a massive shell or swarm of satellites around a star, harnessing nearly all of its energy output. Such a feat would be a hallmark of a civilization far beyond our current technological capabilities. The Dyson dilemma arises from a simple yet profound question. If these structures are possible, why haven't we detected any? One possibility is that these civilizations are intentionally hiding, perhaps to avoid detection by potentially hostile entities. Another, more unsettling explanation is that advanced civilizations might not survive long enough to build such structures. They could self-destruct through war, environmental collapse, or other catastrophic events before reaching the technological level required to create Dyson spheres. This theory forces us to confront the possibility that humanity might face a similar fate. If advanced civilizations tend to destroy themselves before achieving interstellar capabilities, what does that mean for our future? Are we destined to repeat this pattern, or can we find a way to overcome the challenges that have doomed others? The Dyson dilemma also raises questions about the nature of intelligence and progress. Is technological advancement inherently tied to self-destruction, or is there a path to sustainable growth that allows civilizations to thrive and expand across the stars? The absence of detectable Dyson spheres might suggest that the universe is far more dangerous or far more lonely than we've imagined. As we ponder these questions, we're reminded of the fragility of existence and the immense challenges that lie ahead. The Dyson dilemma doesn't just challenge our search for extraterrestrial life, it forces us to reflect on our own trajectory as a species. With this thought-provoking theory in mind, let's turn our attention to another cosmic mystery, the strange patterns and anomalies found in the cosmic microwave background radiation, which could hold clues to the origins of our universe. Now, shifting our gaze to the very fabric of the universe, we encounter a mystery etched into the oldest light we can observe, the cosmic microwave background radiation. This faint glow, a remnant of the Big Bang, serves as a cosmic snapshot of the universe just 380,000 years after its birth. But within this ancient light, scientists have discovered strange patterns and anomalies that defy our current understanding of cosmology. One of the most puzzling features is the so-called cold spot, a region of the cosmic microwave background that is significantly colder than its surroundings. This anomaly spans a vast area of space, and its existence challenges our standard models of the universe's evolution. Some researchers suggest that the cold spot could be evidence of a collision between our universe and another bubble universe in the multiverse. If true, this would imply that our universe is just one of many, each with its own unique physical laws and properties. Other anomalies include unexpected alignments and asymmetries in the radiation's distribution, which some scientists argue could point to the influence of a previous universe. According to certain theories, our universe might be part of an endless cycle of cosmic birth and death, with each iteration leaving behind subtle imprints in the cosmic microwave background. These imprints, if confirmed, could revolutionize our understanding of time, space, and the very nature of existence. Yet not all explanations are so dramatic. Some anomalies might simply be the result of statistical fluctuations or observational errors. However, the persistence of these patterns has kept scientists intrigued, pushing them to explore new models and theories that could account for these cosmic oddities. The cosmic microwave background anomalies remind us that even our most advanced tools and theories have limits. They challenge us to question what we think we know about the universe and to remain open to the possibility that the cosmos holds secrets far stranger than we've ever imagined. As we continue to unravel these cosmic puzzles, let's turn our attention to another profound mystery, the conflict between quantum mechanics and general relativity over the fate of information in black holes, a paradox that could reshape our understanding of reality itself. Now let's dive into one of the most perplexing puzzles in modern physics, the black hole information paradox. At its core, this paradox pits two of our most successful scientific theories against each other, quantum mechanics and general relativity. According to quantum mechanics, information about the state of a system can never be truly lost. It might change form, but it's always preserved. General relativity, on the other hand, tells us that anything that falls into a black hole is gone forever, crushed into the singularity at its center. So, what happens to the information about the particles that fall into a black hole? Does it vanish, or is it somehow preserved? This question has baffled scientists for decades. If information is truly lost, it would violate a fundamental principle of quantum mechanics, shaking the very foundation of our understanding of reality. On the flip side, if information is preserved, where does it go? Some theories suggest that the information might be encoded on the event horizon of the black hole, the boundary beyond which nothing can escape. This idea, known as the holographic principle, proposes that all the information about what falls into a black hole could be stored on its surface like a cosmic hard drive. Another intriguing possibility is that black holes don't destroy information, but instead release it slowly over time through a process called Hawking radiation. Named after the legendary physicist Stephen Hawking, this radiation is thought to gradually evaporate black holes, potentially carrying away the information trapped inside. However, this raises even more questions. How does the information escape, and in what form? The implications of resolving this paradox are enormous. If we can figure out what happens to information in black holes, it could lead to a unified theory of quantum gravity, bridging the gap between quantum mechanics and general relativity. Such a breakthrough would revolutionize our understanding of the universe, from the smallest particles to the largest cosmic structures. As we grapple with these mind-bending questions, let's turn our attention to another cosmic mystery, the enigmatic nature of dark matter, which makes up most of the universe's mass yet remains invisible to us. What secrets does it hold, and how might it shape the fate of the cosmos? Now, shifting our gaze to one of the most elusive mysteries in the cosmos, we encounter the enigma of dark matter. This invisible substance makes up a staggering 85% of the universe's total mass, yet it remains completely undetectable by conventional means. We can't see it, touch it, or directly observe it, but its presence is undeniable. How? Because of its gravitational effects. Galaxies spin faster than they should, and clusters of galaxies bend light in ways that can't be explained by the visible matter alone. Dark matter is the unseen force holding the universe together, and yet we know almost nothing about what it actually is. So, what could dark matter be made of? One leading theory suggests it's composed of exotic particles that don't interact with light or ordinary matter, making them nearly impossible to detect. These particles, often referred to as WIMP, weakly interacting massive particles, could be streaming through you right now without you ever noticing, but here's where it gets even stranger. Some scientists propose that dark matter might not be made of particles at all. Instead, it could be the gravitational footprint of parallel universes existing just beyond our perception. Imagine entire worlds, entire realities overlapping with ours, their presence felt only through the tug of gravity. It's a mind-bending idea that challenges everything we think we know about the universe. The implications of dark matter go far beyond just filling in the gaps in our cosmic understanding. If dark matter is made of exotic particles, discovering them could open up entirely new branches of physics, revealing forces and interactions we've never imagined. On the other hand, if it's tied to parallel universes, it could mean that our reality is just one layer of a much larger, multidimensional tapestry. Either way, solving the dark matter mystery could fundamentally alter our perception of existence itself. But here's the eerie part. Despite decades of searching, dark matter continues to evade detection. Experiments deep underground, in space, and in particle colliders have all come up empty-handed. It's as if the universe is playing a cosmic game of hide and seek, and we're still searching for the rules. This elusive nature has led some to wonder if dark matter is even more bizarre than we've imagined. Could it be a sign of something far stranger, something beyond our current scientific framework? The answers remain hidden, waiting for the next breakthrough. As we ponder the shadowy presence of dark matter, let's turn our attention to another cosmic threat: neutron star collisions. What happens when two of the densest objects in the universe collide, and could such an event pose a danger to life on Earth? Now, let's dive into one of the most explosive and terrifying events in the cosmos: the collision of neutron stars. These incredibly dense remnants of dead stars pack the mass of our Sun into a sphere no larger than a city. When two of these cosmic powerhouses collide, the results are nothing short of apocalyptic. Imagine the sheer energy released in such an event. The collision would unleash a gamma-ray burst, one of the most powerful explosions in the universe. These bursts are so intense that, if one were to occur within a few thousand light-years of Earth, it could strip away our ozone layer, exposing the planet to deadly ultraviolet radiation. The aftermath: a catastrophic blow to life as we know it, with mass extinctions and a devastated ecosystem. But that's not all. the collision would also send ripples through the fabric of space-time, known as gravitational waves. While these waves themselves aren't directly harmful, the sheer force of the event would be a stark reminder of the violent nature of the universe. And if the collision were close enough, the resulting shockwaves could disrupt the delicate balance of our solar system, potentially altering planetary orbits and creating chaos on a cosmic scale. The good news: neutron-star collisions are rare, and the likelihood of one happening near Earth is astronomically low. But the fact that such events are even possible serves as a humbling reminder of the universe's raw power. As we continue to explore the cosmos, discoveries like these remind us just how fragile our existence truly is. With that in mind, let's turn our attention to another mind-bending concept: the holographic universe theory. Could our reality be nothing more than a two-dimensional projection? The answer might just change everything we think we know. Now, let's shift our focus to a theory that challenges the very nature of reality itself: the holographic universe theory. What if everything we see, touch, and experience is nothing more than a two-dimensional projection? This mind-bending idea suggests that our three-dimensional universe might actually be a hologram, a kind of cosmic illusion created by information encoded on a two-dimensional surface. The concept stems from the study of black holes and the strange behavior of information at their event horizons. Scientists discovered that all the information about objects falling into a black hole isn't lost but is instead encoded on its surface. This led to the radical idea that the entire universe could operate in a similar way, with all the information about our reality stored on a two-dimensional boundary. But how could this be possible? Think of it like a movie. A film is essentially a flat, two-dimensional surface, but when projected, it creates the illusion of depth and movement. In the same way, the holographic universe theory proposes that our three-dimensional reality is a projection of information stored on a distant, two-dimensional surface. The implications of this theory are staggering. If true, it would mean that everything we perceive, stars, planets, even our own bodies, are just elaborate projections. This idea blurs the line between reality and illusion, raising profound questions about the nature of existence. Are we living in a simulated universe? Could our entire reality be a kind of cosmic hologram? While the theory is still speculative, there is some intriguing evidence to support it. For example, scientists have found that the cosmic microwave background radiation, the afterglow of the Big Bang, contains patterns that could be consistent with a holographic universe. These findings are far from conclusive, but they open the door to a radical rethinking of how we understand space, time, and reality itself. The holographic universe theory doesn't just challenge our understanding of physics, it also has deep philosophical implications. If our reality is a projection, what does that mean for concepts like free will, consciousness, and the nature of existence? It's a theory that forces us to question everything we think we know about the universe and our place within it. As we ponder this extraordinary idea, let's move on to another cosmic mystery, the cosmic censorship hypothesis. What if the universe is hiding its most extreme secrets from us? The answer might be more unsettling than we imagine. Now, let's venture into a theory that suggests the universe might be keeping its most extreme secrets under lock and key, the cosmic censorship hypothesis. This idea revolves around the notion that singularities, the infinitely dense cores of black holes, are always hidden from our view, shielded by what's known as an event horizon. But why would the universe hide these cosmic anomalies? And what does this mean for our understanding of space, time, and the very fabric of reality? At the heart of this theory is the concept of a singularity, a point where the laws of physics as we know them break down. Inside a black hole, gravity becomes so intense that matter is crushed into an infinitely small, infinitely dense point. But according to the cosmic censorship hypothesis, these singularities are never exposed. Instead, they're always concealed behind the event horizon, the boundary beyond which nothing, not even light, can escape. This raises a fascinating question. Is the universe protecting us from something? Some scientists believe that if singularities were visible, they could create what's called naked singularities, points where the laws of physics cease to function, leading to unpredictable and potentially catastrophic consequences. By hiding these singularities behind event horizons, the universe might be maintaining order and preventing chaos from spilling out into the cosmos. But what if the cosmic censorship hypothesis is wrong? What if naked singularities do exist? The implications would be staggering. Without the protective veil of an event horizon, these singularities could warp space-time in ways we can't even imagine, potentially creating wormholes, time loops, or even entirely new universes. The very fabric of reality could be at risk, and our understanding of physics would need a complete overhaul. The cosmic censorship hypothesis also touches on the limits of human knowledge. If singularities are always hidden, it means there are aspects of the universe that we may never fully understand. This idea challenges our desire to uncover all the mysteries of the cosmos and forces us to confront the possibility that some things might remain forever beyond our reach. As we grapple with this mind-bending theory, let's turn our attention to another cosmic enigma, the alien megastructure mystery. Could the strange dimming of a distant star be evidence of advanced extraterrestrial engineering? The answer might just redefine our place in the universe. Now, shifting our gaze to a star that has baffled astronomers and sparked endless speculation, we arrive at the alien megastructure mystery. This theory centers around Tabby's star, officially known as KIC 8462852, a star located roughly 1,400 light-years from Earth. What makes this star so peculiar is its irregular and dramatic dimming, which has left scientists scratching their heads and even considering the possibility of extraterrestrial intervention. The dimming of Tabby's star was first observed by the Kepler Space Telescope, which noticed that the star's brightness would drop by as much as 22% at irregular intervals. This behavior is unlike anything seen in other stars, where dimming is typically caused by planets passing in front of them or natural stellar activity. The extreme and unpredictable nature of Tabby's star's dimming has led to a range of theories, from swarms of comets to interstellar dust clouds. But one explanation has captured the imagination of both scientists and the public alike: the idea that the dimming could be caused by an alien megastructure. The concept of an alien megastructure, often referred to as a Dyson sphere or Dyson swarm, involves an advanced civilization constructing massive structures around a star to harness its energy. These structures could consist of solar panels, habitats, or other technological constructs orbiting the star, blocking its light in irregular patterns. If such a megastructure were responsible for the dimming of Tabby's star, it would be the first potential evidence of intelligent life beyond Earth, a discovery that would fundamentally alter our understanding of the universe. But what would it mean if we confirmed the existence of an alien megastructure? For one, it would suggest that advanced civilizations are capable of engineering on a scale far beyond anything humanity has achieved. It would also raise profound questions about the nature of such civilizations. Are they peaceful, or could they pose a threat? The implications for humanity's future in the cosmos would be immense, potentially reshaping our approach to space exploration and our place in the universe. Of course, the alien megastructure theory is just one of many possibilities. Scientists continue to explore natural explanations for the star's behavior, such as massive dust clouds or the remnants of a shattered planet. Yet, the allure of the megastructure hypothesis persists, reminding us of the tantalizing possibility that we are not alone in the universe. As we ponder the mysteries of Tabby's star, let's turn our attention to another mind-bending concept: quantum entanglement. How can particles separated by vast distances remain mysteriously connected? And what does this mean for our understanding of reality? The answers might just stretch the limits of our imagination. Now, stepping into the strange and counterintuitive world of quantum physics, we encounter one of the most baffling phenomena in science: quantum entanglement. Imagine two particles separated by vast distances, yet somehow remaining intimately connected. What happens to one instantly affects the other, no matter how far apart they are. This bizarre connection, which Albert Einstein famously called spooky action at a distance, challenges everything we think we know about reality. Quantum entanglement occurs when two particles become linked in such a way that the state of one particle directly influences the state of the other, even if they are light years apart. For example, if one particle is measured and found to be spinning in a particular direction, its entangled partner will instantly assume the opposite spin, regardless of the distance between them. This instantaneous connection defies the laws of classical physics, which state that nothing can travel faster than the speed of light. Yet in the quantum realm, this rule seems to be broken. The implications of quantum entanglement are profound and, frankly, unsettling. If particles can communicate instantaneously across vast distances, what does that mean for our understanding of space and time? Could this phenomenon hint at a deeper, hidden layer of reality that we have yet to comprehend? Some scientists speculate that entanglement might even pave the way for faster-than-light communication, a concept that could revolutionize technology and our ability to explore the cosmos. Imagine sending messages across the galaxy without the delays imposed by the speed of light. It's a tantalizing possibility. However, the eerie nature of quantum entanglement also raises philosophical questions. If particles can be so deeply connected, does that mean the universe is fundamentally interconnected in ways we can't yet perceive? Could this phenomenon suggest that separation is an illusion, and that everything in the cosmos is part of a single, unified whole? These questions push the boundaries of our understanding, forcing us to rethink the very fabric of reality. While the practical applications of quantum entanglement are still in their infancy, researchers are already exploring its potential in fields like quantum computing and cryptography. These technologies could one day transform how we process information and secure communications, leveraging the strange properties of entangled particles to achieve what was once thought impossible. As we grapple with the mysteries of quantum entanglement, let's turn our attention to another cosmic enigma: phantom energy. What if the universe's expansion accelerates to the point of tearing apart galaxies, stars, and even atoms? The answers might just redefine our understanding of the cosmos. Now, shifting our gaze to the far future of the cosmos, we encounter a theory that paints a chilling picture of the universe's ultimate fate: phantom energy. This mysterious force, a hypothetical form of dark energy, could drive the universe's expansion to such extreme speeds that it rips apart everything in existence. Imagine a scenario where galaxies, stars, planets, and even atoms are torn to shreds as the fabric of space itself stretches beyond its limits. This catastrophic event is known as the Big Rip, and it's one of the most terrifying possibilities for the end of the universe. Phantom energy is thought to have a peculiar property: its density increases over time, unlike ordinary dark energy, which remains constant. As the universe expands, phantom energy grows stronger, accelerating the expansion faster and faster. Eventually, this runaway effect could become so powerful that it overcomes the forces holding matter together. Galaxies would be pulled apart first, drifting away from each other into the void. Next, stars and planets would be ripped from their orbits, disintegrating into cosmic debris. Finally, even the atoms that make up all matter would be torn apart, leaving behind a universe of isolated particles unable to interact with one another. The Big Rip isn't just a dramatic end, it's a profound challenge to our understanding of physics. If phantom energy exists, it would mean that the universe's expansion isn't just slowing down or stabilizing, but accelerating toward an inevitable, violent conclusion. This raises unsettling questions about the nature of dark energy and the forces shaping our cosmos. Could phantom energy be a sign of something even more fundamental that we've yet to discover? Or is it a grim reminder that the universe's fate is far beyond our control? What makes the Big Rip particularly haunting is its inevitability. If phantom energy is real, there's no way to stop it. No technology, no matter how advanced, could counteract the sheer power of a force that can tear apart the very fabric of reality. It's a sobering thought that the universe, in its final moments, could dissolve into chaos, erasing all traces of the galaxies, stars, and life that once existed. As we ponder the implications of phantom energy and the Big Rip, let's turn our attention to another mind-bending concept, the idea that our universe might be just one of many in an infinite multiverse. What if there are countless other realities, each with its own laws of physics and possibilities? The answers might just redefine everything we think we know about existence. Now let's venture into a theory that stretches the boundaries of imagination, the parallel universe theory. What if our universe isn't the only one? What if there are countless other universes, each with its own unique set of physical laws, histories, and even versions of you and me? This mind-bending idea suggests that our reality is just one thread in an infinite tapestry of parallel worlds, collectively known as the multiverse. The concept of parallel universes isn't just science fiction, it's rooted in serious scientific theories. One of the leading ideas comes from quantum mechanics, where every decision or event could spawn multiple outcomes, each playing out in a separate universe. For example, in one universe, you might have chosen a different career path, while in another, humanity might have never evolved at all. The possibilities are endless and the implications are staggering. But the multiverse doesn't stop there. Some theories propose that these parallel universes could have entirely different laws of physics. Imagine a universe where gravity is 10 times stronger or where time flows backward. These alternate realities could be so alien that they defy our understanding of existence itself. And yet, they might exist hidden from us just beyond the edges of our observable universe. The idea of a multiverse also raises profound questions about our place in the cosmos. If there are infinite universes, does that mean every possible version of reality exists somewhere? Could there be a universe where humanity thrives in harmony, or one where we never existed at all? The thought is both exhilarating and humbling, reminding us of the vastness of existence and the mysteries that lie beyond our reach. What's even more intriguing is the possibility that these parallel universes might not be entirely separate. Some theories suggest that they could occasionally interact, creating ripples or anomalies that we might detect. Could strange cosmic phenomena like unexplained gravitational waves or mysterious particles be evidence of these hidden worlds? The search for answers continues as scientists explore the edges of reality in pursuit of clues. As we ponder the infinite possibilities of the multiverse, let's turn our attention to another cosmic mystery, the enigmatic cosmic strings. These hypothetical one-dimensional defects in space-time could hold the key to understanding the very fabric of our universe. What secrets do they hold, and how might they shape the cosmos as we know it? The answers could redefine our understanding of reality itself. Now, shifting our gaze to another cosmic enigma, let's unravel the mysteries of cosmic strings. These hypothetical one-dimensional defects in space-time are thought to be remnants from the earliest moments of the universe, formed during the intense energy fluctuations of the Big Bang. Imagine them as incredibly thin, incredibly dense threads stretching across the cosmos, thinner than an atom but with the mass of an entire galaxy. Their existence, while still theoretical, could hold profound implications for our understanding of the universe. Cosmic strings are believed to warp the fabric of space-time itself. Picture a rubber sheet stretched tight. Now imagine placing a thin, heavy wire on it. The sheet would bend and distort around the wire, creating ripples. Similarly, cosmic strings could create distortions in space-time. potentially leading to observable effects like gravitational lensing, where light from distant objects bends around the string, creating strange, duplicated images in the sky. These distortions might even leave imprints on the cosmic microwave background radiation, the faint afterglow of the Big Bang, offering clues to their existence. But what makes cosmic strings truly fascinating is their potential to influence the structure of the universe. Some theories suggest that these strings could have played a role in the formation of galaxies and galaxy clusters, acting as cosmic scaffolding around which matter gathered. If true, they might be the hidden architects of the large-scale structure we see today. Yet, their elusive nature makes them incredibly difficult to detect, leaving scientists to rely on indirect evidence and mathematical models to study them. The mysterious nature of cosmic strings also raises intriguing questions about their behavior. Could they vibrate, creating gravitational waves that ripple through the universe? Might they intersect or loop, forming complex structures that defy our current understanding of physics? The answers to these questions could revolutionize our knowledge of space-time and the fundamental forces that govern the cosmos. As we ponder the enigmatic nature of cosmic strings, let's turn our attention to another chilling possibility: the threat of an alien virus. What if extraterrestrial microorganisms carried by meteorites or spacecraft could pose a catastrophic risk to life on Earth? The implications are as unsettling as they are fascinating, and they remind us of the countless mysteries that still lie beyond our grasp. Now, let's venture into a theory that feels like it's straight out of a science fiction thriller, but with a chilling twist. It could be real. Imagine this: extraterrestrial microorganisms, tiny hitchhikers from the depths of space, arriving on Earth via meteorites or even spacecraft. These alien viruses, if they exist, could pose a threat unlike anything we've ever encountered. The idea isn't as far-fetched as it might sound. Scientists have long debated the possibility of panspermia, the theory that life on Earth might have originated from microorganisms carried here by comets or asteroids. But what if these space travelers weren't just the building blocks of life, but also potential destroyers? Alien viruses, adapted to environments we can barely comprehend, could be completely foreign to our immune systems and ecosystems. Think about it. Our planet's history is filled with examples of how even small changes in biological systems can lead to massive disruptions. The introduction of invasive species, for instance, has caused ecological disasters. Now, imagine something far more extreme: a virus or microorganism that doesn't just disrupt ecosystems but could potentially wipe out entire species, including humans. The risks don't stop there. If these microorganisms were to interact with Earth's existing life forms, the results could be unpredictable. They might mutate rapidly, combining with Earth-based pathogens to create new, unstoppable diseases. Or they could release toxins or chemicals that our planet's biology has no defense against. The consequences could range from widespread illness to the collapse of entire ecosystems. What makes this theory even more unsettling is the possibility that we might not even see it coming. Alien viruses could be microscopic, undetectable by our current technology until it's too late. And if they arrived on a meteorite or a spacecraft, they could spread rapidly, carried by wind, water, or even human activity. But here's the twist: while the idea of an alien virus is terrifying, it also raises profound questions about our place in the universe. Are we alone, or are we part of a vast, interconnected web of life? And if life exists elsewhere, what forms might it take? The alien virus threat reminds us that the cosmos is full of unknowns, and some of them might be closer than we think. As we grapple with the implications of this theory, let's turn our attention to one final, mind-bending idea: the end of time itself. What if time, the very fabric of our existence, could simply stop? The thought is as unsettling as it is fascinating, and it challenges everything we think we know about the universe. Now, let's step into the final and perhaps most mind-bending theory of all: the end of time itself. What if time, the very framework that structures our existence, could simply stop? This isn't just a philosophical musing. It's a scientific possibility that challenges everything we think we know about the universe. Imagine a moment when the ticking of the cosmic clock ceases, freezing reality in a single, eternal instant. No past, no future, just an unchanging present. It's a concept that feels almost impossible to grasp, yet it raises profound questions about the nature of reality. From a scientific perspective, the end of time could occur if the universe reaches a state where all processes grind to a halt. This might happen if entropy, the measure of disorder in the universe, reaches its maximum, leaving no energy available to drive change. In this scenario, the universe would become a static, lifeless expanse with no motion, no evolution, and no passage of time. It's a chilling thought, especially when you consider that time is the foundation of everything we experience, our memories, our plans, even our sense of self. But the implications go even deeper. If time were to end, what would happen to consciousness? Would our thoughts and experiences simply freeze, trapped in an eternal moment? Or would they cease to exist altogether? Philosophers have long debated whether time is an objective feature of the universe or a construct of the human mind. The end-of-time theory forces us to confront these questions head-on, blurring the line between science and philosophy. What makes this idea even more unsettling is its unpredictability. Unlike other cosmic threats, the end of time wouldn't come with warning signs or dramatic events. It could happen suddenly, without any way for us to prepare or even comprehend what's happening. One moment, the universe would be as we know it. The next, it would be frozen in an unchanging state. The sheer finality of this scenario is both terrifying and awe-inspiring. Yet, as unsettling as this theory is, it also invites us to reflect on the nature of existence. If time is finite, what does that mean for our lives and the choices we make? Does it give our actions more meaning, knowing that time is a precious, limited resource? Or does it render everything ultimately meaningless, destined to be frozen in an eternal instant? These are questions that have no easy answers, but they remind us of the profound mysteries that still surround us. As we wrap up our journey through these 30 terrifying space theories, it's clear that the universe is far stranger and more mysterious than we often realize. From the collapse of the cosmos to the end of time itself, these ideas challenge our understanding of reality and leave us with more questions than answers. Which theory do you find the most unsettling? Let us know in the comments below, and don't forget to subscribe for more mind-bending explorations of the cosmos. Thanks for watching, and until next time, keep looking up at the stars because the universe is full of wonders waiting to be discovered. As we come to the end of this cosmic journey, it's impossible not to feel a mix of awe and unease. These 30 terrifying space theories have taken us to the edge of what we know and beyond. From the collapse of the universe in the Big Crunch to the eerie silence of the Fermi paradox, and from the chilling possibility of a simulated reality to the ultimate end of time itself, each theory forces us to question the very fabric of existence. They remind us that the universe is not just vast but deeply mysterious, filled with phenomena that defy our understanding and challenge our place in the cosmos. What's truly remarkable is how these theories bridge the gap between science and philosophy. They don't just explore the mechanics of the universe, they delve into the profound questions of meaning, purpose, and the nature of reality. Whether it's the idea of a multiverse with infinite versions of ourselves or the haunting thought of a dark forest where civilizations hide in fear, these theories push us to think beyond the limits of our imagination. They remind us that the universe is not just a place of wonder, but also one of uncertainty and danger. But perhaps the most striking takeaway is how these theories connect us. They remind us that, no matter how advanced we become, we are still explorers in a vast, uncharted cosmos. Each theory invites us to reflect on our own existence, our choices, and our future. They challenge us to keep asking questions, to keep seeking answers, and to never stop marveling at the mysteries that surround us. So, which of these theories left you the most unsettled? Was it the idea of a rogue black hole tearing through our solar system, or the thought of a vacuum decay catastrophe erasing everything in an instant? Let us know in the comments below. We'd love to hear your thoughts. And if you enjoyed this journey through the cosmos, don't forget to hit that subscribe button and ring the notification bell. There's so much more to explore, from the depths of space to the frontiers of science and philosophy. Thanks for watching, and remember, the universe is full of wonders, and the next mind-bending discovery could be just around the corner. Keep looking up.